of these is a regression. The linear was a best fit line. Then we're going to try a best fit parabola, and we're going to try a best fit exponential. We're going to try all of these. Oh yeah, we're crazy like that. So grab your TIs. Does everybody have the scatter plot? No. Okay, we'll get that in there. If you have your scatter plot, I have the best fit line there. It's doing a crappy job, yes. It's doing a crappy job. Let's go back in. Press your stat button. Press your stat button. Go over to calculate. Scroll down. Right past lid ray is something called quad ray. That's how you find the best fit parabola for a set of data. You do it, everything else is exactly the same. Make it a scatter plot. Going into the stat calc menu, you just grab quad ray instead of lid ray. Now this is why I think it's best to put the Y1 after that, because you want to put the graph on the data as well, yes? You want to put the graph on the data as well. So, in case you've forgotten this, I think it's on page 4 of your booklet. Here is real quick, if you don't have that handy. Bars button, right arrow, enter, enter. It is on page 4 of your booklet. I've got it, I think it's the top of page 4 of your booklet, just so you know how to access that. When you press enter, now, you'll think a little bit and then fires them all out. Look at the A, B, and C. Does that sound familiar-ish? Yes, I saw 3 pairs of eyes that I was looking at and look up at the board. Exactly, the A and the B and the C are those values from the equation. The A value in this case is that 1.68. Please, Danny, yes?
I have an extra line that says r squared equals...
That's okay. Those are called, what the hell those are called? They're called something. Pearson's coefficients of, I forget. You can ignore them. People tend to misuse them, so I tend to just ignore them altogether. I can turn them off afterwards if you want me to. I'd be happy to do that. Anybody else have like an r squared and an r? If they bother you, I can turn them off for you. You don't need them for this class. They're not important. So the more important thing is I want to see it. So press graph. Just press graph or press zoom 9, Francis. Zoom 9. I like the woo. That was good. We like how that fits, yes? We like it. It works nicely. It works. So let's put that in our back pocket. Let's put that in our back pocket. Let's try this exponential, which also garnered the same number of votes, yes? It also garnered the same number of votes. Let's try the exponential, although I'm liking the way that fits. That's good. So, stat calc. I'm going back. We like the parabola, but we're also going to go back and try the exponential, because that also garnered the same number of votes. We got to go down and find x ray. It's down a little bit further. There it is. X ray, 0.
Wait, where are we at?
The same place, just down a little further.
Where are we lost?
That's what it is.
You're in the same place lid ray was, you're in the same place quad ray was. And then do the exact. This is the beauty of the booklet. The booklet applies to everything except sometimes you have to change the regression you're running. That's it. And that's easy enough. You just put little notes on there as you go. So x breg, y1, yes? Good. I'm seeing some frowns. This is good.
Wait, hold on.
We're doing the same thing every time. Please, Randall.
Has Pearson trigonometric relation?
Thank you. I forgot all that stuff in the middle. Pearson's blah, blah,
I
blah.
was trying to get my thing, but I don't remember.
Don't worry. Because look what happens when you try to run an exponential regression. Well, it doesn't like it. Well said, Joanne. That was you. I'm not sure who that was, but I think it was Joanne. Good. Why doesn't it like it? Does anybody have a vote as to why it doesn't like it? Please, Alicia.
Because aren't domains where it stops at a certain point and at a certain point,
Oh.
the point may not be a
Perfect. Love that back there. The problem is in the equation. We have a data point that it doesn't like, and it shouldn't like it exponentially. Remember the first data point in our data set? I was sitting up there by Pete, and I said, ready, set, go. What was that data point right there? 0, 0. That would have to fit on that equation over there. 0, 0 would have to fit on the exponential equation. If you put a 0 up here as a value of x, what happens when you raise a base to the 0 power? Just you have to think back now to your math, previous math. You get 1. A number to the 0 power equals 1. We'll talk way more about that later. Way more about that later. So that's 1, which means 1 times A would be equal to A. But the TI thinks it equals 0. So that's what's called a contradiction. It's getting confused because it's expecting a numerical value, and well, it's expecting a non-zero numerical value, but you're giving it a 0, which is a 0 value, and then it's like, I can't do this math. Yes, you can't do this math. That's the problem with exponential modeling. This is not exponential data. Because we could get rid of that first data point. We could throw it away and redo it the rest of it, but I don't want to do that. That loses where I started, yes? So, for now, let's push the pause button on exponential modeling, because this is not exponential, and let's be stoked that the quadratic model fit as well as it did, yes? Please, Joanne.
So I was right when I raised my hand with the quadratic.
Well, in this case, yes! And what I was asking about, the reason I was asking about who had studied gravity and its effects before, it is well known that gravity operates quadratically on data as a function of time. You can actually calculate those kinds of things when you're very up high. If you're up high on a cliff and you need to know how big the cliff is, you can just take a large rock, have your friend with their smartphone start a stopwatch, drop the rock, start the stopwatch, and then listen for when it hits. Based on that time, you can figure out how high the cliff is, based on an equation just like this one, because it's known that gravity is quadratic and behaves in certain ways. So I knew the answer coming into the day what it was going to look like. But I love the vote for exponential, because exponential and quadratic appear to curve similarly. But when we start into it next week, you'll see how they differ. They differ in important ways. But in this particular case, this is most definitely quadratic. So let's go back to our quadratic fit, yes? Let's go back to our quadratic fit. Just quit. When you get an error like that, you just hit quit. Just hit quit. And now here's a trick. How many know this trick? You can press second enter, and it recalls the thing you did twice before. Remember that trick from your previous math classes? Second enter gets you back. So as I go second enter twice, it pulls back up quad reg y1. Just press enter again, just runs it again. You never, well, you did right now. It's kind of a nice thing. Like if you do something like with a lot of steps, you screw it up. It's a nice one to go back in and kind of fix it as you go. Second enter. Yeah, second enter. It'll just keep cycling through the last few things you did.
Oh.
There's 243 from Thursday. Still 243 from Thursday. I must have done it a lot. That's the end of 244 from Thursday. There's you guys from Wednesday. Yeah. Oh, that was what my son got into my backpack. And eventually I'm going to find quad reg again, and I can press it again. There it is. So anyway, this, I believe, I like the way that looks, friends. I think it looks fantastic. It catches the 0, 0. What I really like about it is it's curving more and more as it goes up. I really like that. I really like that. Because it does a very good job of describing our data. It's not perfect, correct? It's not perfect. It misses that data point. It's too small for that data point. It's too big for that data point. But we knew that was going to happen because we had a couple inconsistencies in our data anyway, remember? When we were going through the changes in x on a constant change of y, they weren't doing exactly what they were supposed to do, but they're doing-ish what they're supposed to do. So let's take this down as our model. Okay? Switch the camera over. Time check, friends. What time is it?
12 minutes.
7, 8.
10 minutes till. That's perfect. We can wrap this up really quickly. This is fantastic. Thank you, friends.